Hi, this is Advanced Math, Chapter 12, Part A, Page 2, the walkthrough, which you can look at if you're having trouble figuring out what's going on. We just talked about the Xenops Bird Ranch bird cage for the Yorkshire Canaries, um, and how that relates to something mysterious called vectors. What we're going to look at in the rest of the section is some of the terminology that we're going to need to have sort of in hand to talk in more depth about vectors in 3 dimensions. In this particular section, we're going to talk about how to plot points and planes and work in 3 dimensions graphically instead of just 2 dimensions. So I'm zoomed in on this. So I've got a couple of things, a 2D Cartesian plane and a 3D Cartesian-like plane that we're going to use to talk about the basics here. So on the left is the 2D plane that you're familiar with. If you want to locate something in two-dimensional space, there's an x-coordinate and a y-coordinate. The x-coordinate is determined horizontally and the y-coordinate is determined vertically. And as we go to 3 dimensions, I want to connect these two, the 2 dimension and the 3 dimension. So let's say if we're looking at a 2 dimensional plot like this one here, let's imagine that we're looking down on a floor. And to make that a little more concrete, I'm going to put in some floorboards and a rug on the floor. So here's a rug, and on the floor there are some floorboards. Well, it takes a stretch to actually imagine that's a floor, but okay. So we have floorboards and a rug on our floor. And so we could always, if we wanted to, locate any position on the floor. So there's a position on the floor. It's at coordinates 2, 3. And that's the nice thing about Cartesian coordinates. It's a way of locating things in two-dimensional space. So that's something we've grown accustomed to over time. Now, in a 3 dimensional case on the right, what we want to do is imagine that we're going to take this floor that we already have, we're going to rotate it and plop it down. So we're now looking across the floor, and it has the floorboards and the rug that we were talking about earlier. So I'm going to sketch in a sort of a perspective drawing of what this rug looks like now. There's the rug and the floorboards. Kind of go like this. So now we've got a floor, which is actually in a 3 dimensional view, kind of looks like the way you would see a floor if you're looking out into a room. Um, there's the corner with the wall over here. There's another corner with a wall over here, and this is the corner of your room. There's your rug, and these are your floorboards. Now, to fill this out, we could say, hey, this is really a room, and the room has a window with some drapes. And maybe on the wall to our left, we have a door with a window in it and a doorknob. So now we're sort of, again, this is a way to draw out your own experience with seeing things in 3 dimensions. So we've got now a floor, we've got a firewall with a window in it, and a wall on the left with a door in it. And we're looking into the corner of a room. So again, we could locate a point on the floor, the same one we had over there at 2, 3. So we go over to 2 on the x-axis and 3 on the y-axis and find where those two meet on the floor. So 2 and 3. So there's our point 2, 3 on the floor. But now, in working in 3 dimensions, we have the ability to find positions of things in the room, in the space inside the room. So if you raise something vertically here off that point on the floor, you now have the ability to specify the location of points in three-dimensional space. Okay, we're going to talk a little bit more about that with on the next page, but I just wanted to give you that way of looking at things. Um, this three-dimensional coordinate system is called a right-handed coordinate system. And the reason for that is shown here. And I'm going to try to put these two coordinate systems together. When we draw a three-dimensional coordinate system in advanced math, and most mathematicians will do this, they draw it with the x-axis kind of coming out of the page at you. Again, I was describing this as a three-dimensional room where the far wall is parallel to the page and the floor is the x and y axes that we had over here before. So we're taking this representation in two dimensions and flopping it down on the floor in this three-dimensional view, and then raising up the wall in the z-axis direction. Now, you can arrange an x, a y, and a z-axis in two different ways, and this picture at the bottom is describing one of those ways called the right-handed system. And it's not super important that you understand this. It's just we're always going to use a right-handed system, and we always follow the convention that the x-axis comes out of the page at us. Right-handed system means that if you have an x, y, and z axis system like this, and you were to see it at three-dimensional space, and you held your right hand with your fingers clenched and your thumb sticking out such that the direction that your thumb was pointing in was aligned with the z-axis, then your fingertips, as you curl them into a fist, would be curling in this direction. So a left-handed system would do the same thing with your left hand. In a left-handed system, you'd have z-axis, x-axis here, and y-axis here. This would be a left-handed system. Now, if you're paying attention, you noticed probably that, hello, these two three-dimensional systems that we drew here, this grid, three-dimensional framework, and this one are different because this one we have x, y, and z, and this one it's x, y, and z. And the one down on the bottom here, the z-axis is the one coming out of the page. And that's not the convention in mathematics to draw it that way, but these are both right-handed systems. So what I want you to do is imagine taking this three-dimensional frame on the bottom and in your mind, pick it up and rotate it around and see if you could line it up to match this one. And you could. If you tip this z-axis up and make the x and y sit on the floor and then turn it a little bit, you'd have the x and y and the z all matching up. So it's a right-handed system. If you started with this left-handed system, there's no way you can pick that up and rotate it and have it match the right-handed system. So they're fundamentally different. Neither one is right or wrong in a mathematical sense. It's just that we usually will use the right-handed system. All right, next up we'll talk about on page 3 how to graph a point in a two-dimensional and a three-dimensional system. We've already talked about that a little bit here. We'll do it again.